if we derive cosine of x, we'll get a negative sine of x. And then again, of course, if we derive tangent x, we'll get a secant or secant squared x. Now, we do the reverse, okay? So when we get the antiderivative of cosine of x, that's equal to sine of x plus c. So we just go to the reverse, right? And then the antiderivative of sine x is basically negative cosine of x, okay? And then secant squared x is equal to tangent x plus c. Okay, so it's just the reverse of everything that we have learned from last chapter. Now, let's try to have, let's have some examples. Let's try out some questions. Let's have number 1, integrate the following. So we have letter A. So we have 1 plus cosine of x. So how do we integrate this? So basically, integrate each of this. So the antiderivative of 1 is simply x. I think everyone knows that. And then the antiderivative of cosine x from here is sine of x or sine x. And then don't forget your plus c. So yeah, this is your answer for letter A. Again, you need to get the antiderivative of each. So antiderivative of 1 is x. Antiderivative of cosine x is sine x plus c. Right, now let's go to letter B. Now, what if there's a coefficient in front of the function or the trigonometric function, okay? So basically, it's the same thing like what we did before in our previous topic. You set aside 3 like this, and then what is the antiderivative of cosine x? So it's sine x, okay? And then minus 2. So you put down negative 2 here, okay? So this is negative 2, but then if you get the antiderivative of sine x, this is equal to a negative cosine of x. So therefore, your final answer is a positive 2 cosine x. Okay, I hope that's clear why this is plus 2 cosine x and then plus c. So that's your answer for letter B. Okay. And then what if we have limits? Okay, now let's have limits. So let's get the antiderivative of 2 plus sine x from 0 to pi over 2. Okay. So first, basically, we get the antiderivative of this. So the derivative of 2 is simply 2x. And then the antiderivative of sine x is a negative cosine x. Okay. And then now we find the limit from 0 to pi over 2. So basically, using this equation here, so we plug in the upper limit first. Okay, so pi over 2 here for both of the x values minus the lower limit. So same expression, and then we plug in 0 for our lower limit. Okay, so simplifying this, so you'll get pi minus 0. Okay, so take note of this. Make sure that your calculator is in radian form. Cosine of pi over 2 is 0 minus, basically this is 0, and then cosine of 0 is 1. Okay, you just plug this in your calculators, and remember it should be in radians. Okay, so simplifying this, your final answer is pi plus 1. Okay, you don't have to express this in decimals. This will do. All right, so do you have any questions, Sec 4, with example letter C? No questions, Sec 4?
I don't really get it.
Which one, Justin?
Oh, I was in the toilet for a while.
Oh, all right. Okay. So maybe Justin, I'll come back to you, okay? But let me do this one quickly, okay? So basically, if you're in page 441, okay, so the antiderivative of each of this trigonometric function is this, okay? It's just the reverse of what we have learned from derivatives, okay? So the antiderivative of cosine x is sine x. The antiderivative of sine x is a negative cosine x, and then the antiderivative of secant squared x is tangent x, okay? So for letter A and letter B, we have indefinite integrals, right? So our answer here are expressions instead of numbers, okay? So how do we integrate this? So we basically integrate each of this, right? So the antiderivative of 1 is x. And then the antiderivative of cosine x from this table here is sine x. And then plus c. That's how you get your answer for letter A. All right. Now, how about for letter B? Uh, you need to get the antiderivative of each of this. So the antiderivative of 3 cosine x minus the antiderivative of 2 sine x. So getting the antiderivative of this, since you have a coefficient here, you just put that here. Okay, you set this aside. And then, what is the antiderivative or the answer for cosine x? So it's sine x. So this is your answer for this. Okay, that's it. And then how about for this? Okay, so since you have a negative 2 here, you put negative 2 here. Okay, you set aside negative 2 first. And then when you derive sine of x, your answer here is a negative cosine x, right? So when you multiply this, you'll get a positive 2 cosine of x and then plus c. That's for letter B. Now for letter C, this is a definite integral. That means that your answers will be numbers. Okay. Okay, so we have this question here. So we find the antiderivative of 2 plus sine x from 0 to pi over 2. What's the first step here? We find the antiderivative of the expression first. So what is the antiderivative of 2? It's 2x. Okay. And then what is the antiderivative of sine x? It's a negative or minus cosine x. So that's it, right? And then after this, we need to find the answer from 0 to pi over 2. So this is an angle, right? So 0 and then pi over 2. Then pi and then 3 pi over 2, right? Okay, so that means we just need to plug in the lower and then the upper limit. So how do we answer definite integrals? So upper limit minus the lower limit. So for this expression here, so it came from here, and then we plug in the upper limit here, and then minus the lower limit, which is 0, right? So you just simplify this in your calculator. Okay, so this one, you cancel that. So you get pi. And then when you plug this in your calculator, cosine pi of 2, you'll get 0. And then this is basically 0. And then cosine of 0 is 1. So simplifying this, you'll get pi plus 1. Okay, so that's okay. I'll do the first one. Okay, so how do we answer this? Now, if we have, again, definite integrals, right? So first things first, you need to get the antiderivative of cosine of x. So that's basically sine x, right? And then, you know, find for the lower and upper limit, okay? So now this thing here becomes sine of upper limit, so pi over 6 minus sine of 0 being the lower limit. So what's your answer here? Okay, so for this one, again, you need your calculators, and then it should be on radian form. Okay, so sine of pi over 6. So that is 1/2, right? And then minus, what is sine of 0? That is 0. So basically your answer here is 1/2. Okay. Okay, so your answer for 3A is 1/2. Do you have any question, class? Sec 4? No question? Okay. So let's have number 3, letter E. Okay. So we need to find the antiderivative of 1 minus 2 sine of x from 0 to pi over 2. Okay. So we again need to get the antiderivative of 1 minus 2 sine of x, right? So what is the antiderivative of 1? It's x, right? And then minus 2, what is the antiderivative of sine x? Okay, so this is negative cosine x, right? So negative cosine of x. So what happens with this? So instead it becomes positive 2 cosine of x. And then we now find for the upper and lower limit from 0 to pi over 2. So writing the equations, so we'll have pi over 2 plus 2 cosine of pi over 2. This is your upper limit minus for the lower limit. So it's 0 minus 2 cosine of 0. Okay. So simplifying this, class, so what do we get? So we have pi over 2 here plus, what is cosine of pi over 2? You can get your calculators. So it's 0, right? So 0 times 2 is 0. Okay. And then minus, what is this? So negative 2 cosine 0 again. So this is minus negative 2, because cosine 0 is, this is equal to 1. Okay, so 1 times negative 2 is negative 2. Negative 2 times negative is, this is now, okay, let me just write it as a minus 2. Okay, so what's our answer here? So our answer here is pi over 2 plus 2. Okay, so that's your answer for 3. Do you have any question, class? Like 4? I think I made a mistake. Wait. Okay, so I saw this. Okay, so this is plus, right? Okay, so this is not minus. So this is supposed to be minus 2, not plus 2. This is thick. Okay, this one. So careless. So that's the final answer. Okay, this one. So last one. Okay, so let's have 3J. Okay, 3J. We have to find the antiderivative of cosine of 2x plus pi over 3 from pi over 12 to pi over 3. Okay. So first, again, we need to find the antiderivative of 2x of cosine of 2x. So that's sine. Okay, but what happens with this? It becomes 1/2 sine of 2x plus pi over 3. Okay, and then let's find for the upper and lower limit from pi over 12 to pi over 3. So this is now equals to, so 1/2. So upper limit first, right? So sine times 2 times pi over 3. Let me just use a different color marker. So this is uh, pi over 3, and then plus pi over 3. Okay, then minus, again, 1/2 sine. So this is now 2 times pi over 12 plus pi over 3. Okay, so let's simplify each term now. Okay, so this is equal to sine of 2 pi so this is basically 1/2 times 0. Okay, minus this is 1/2. Okay, class, again, you can plug this everything here in your calculators. Okay, so when you plug this is sine of 2 pi over 3. Okay, plus pi over 3. Okay, so that's equal to 0. Then how about this? Okay, so sine of pi over 6. Okay, so this is pi over 6, right? And then plus pi over 3. So this is equal to 1. Okay, so when you plug this, that's equal to 1. So therefore, what's your answer here? Your answer is simply -1/2. Okay, so do you have any question, class? All right, so let me have this now. So 3D here. So you got to get the antiderivative of secant squared x from 0 to pi over 4. So first things first, you need to get the antiderivative of secant squared x, which is tangent x. Now we get the answer for this from 0 to pi over 4. So tangent of pi over 4 for your upper limit minus tangent of 0 for your lower limit. So your answer is 1. Okay. For 3f, this is a bit tricky. Okay. Okay, so we need to get the antiderivative of 3 cosine x minus 2 from 0 to pi over 6. So first things first, get the antiderivative of this. So this is 3, and then the antiderivative of cosine x is simply sine x. And then the antiderivative of minus 2 is minus 2x. Okay, so this is your answer, right? So let's now find the answer from 0 to pi over 6. So for your upper limit, so you get 3 times sine of pi over 6 minus 2 times pi over 6 minus, for your lower limit, 3 times sine of 0 minus 2 times 0. So simplifying this, by the way, class, take note. You don't have to type this one straight in your calculator. Please answer them term by term. So type this, so you'll get 3 over 2. Then minus this one is pi over 3. Okay, don't type this because you'll get a decimal. Okay, usually we express our answers in terms of pi. That's why you have pi here. Okay, so anyway, this one gives you 3 over 2. Simplifying this, you'll get pi over 3. Okay, so you got 3 here. And then this one here, basically, this is a 0. Okay, so therefore, your final answer is just this. So 3 over 2 minus pi over 3. Okay, so that's for 3. Okay, so that wraps up for our integration of trigonometric functions. Okay, so let's finish this chapter with this one, integration of exponential functions. Okay, so we only have one. Okay, just one. Okay, so we have this here. If you please turn your books on page 444, 444. Okay, so Okay, okay. So page 444. These are the identities that you need to learn, okay, for each integration. So basically, when you integrate e or natural log, okay, with e or exponential raised to x, that is equal to the same thing, right? Plus c, it didn't change at all. Okay. Okay. And then if now your index is a negative, it will affect the value of e. E will become a negative e. Okay. And then same with this, it's still negative x. Okay, it didn't change, it just affected the value of e or the sign of e. It's now negative. But then, if your index is an expression like this, we have, let's say, e raised to ax plus b, getting the antiderivative of this, you'll get a fraction here, just like a while ago. Okay, so a here becomes 1 over a. And then write the whole question again, the whole term again, like this. Okay, so what's different with this? Okay, so if you have observed, we just added this, and then that's it. Okay, we don't have to change anything, right? So it's basically, we just add 1 over a. Okay, same with this and this, we just have negative here, and then we have 1 over a here. Okay, so now let's apply this. Okay, so let's integrate exponential functions. So let's have letter a. So what is the antiderivative of e raised to 2x plus 1? Okay, 2x plus 1. So what happens here? So 2 is your coefficient. So what happens with 2? It becomes this fraction here. So it becomes 1 over 2. Okay, so this is y, this is 1 over 2. And then just write this thing again, and then that's your answer. Just that. Okay, so we just added 1/2 in front of e for the, yeah. Okay, so that's A. So let's have letter B. Now for letter B, let's find the antiderivative of e raised to 3 minus 2x. Okay, so basically, negative 2 is your coefficient here. That's why this is 1 over negative 2, or maybe negative 1/2. Okay, and then copy this again, and then that's it. That's your answer. Right? It's not very hard. Actually, integration of exponential functions are the easiest. Okay. Then let's have letter C. All right, now letter C and D, we now have limits. Okay. So for letter C, we find the antiderivative of e raised to 2x from 0 to 2. First things first, we need to get the antiderivative of e raised to 2x. So you have your coefficient here, you have 2x. That's why you have here over 2, 1 over 2, or 1/2. And then write this thing again. And then we now find for the value of the limit from 0 to 2. Then what do? Take note of this. You can set aside 1/2, and then you perform the limit, or you answer the limits, okay, inside a bracket. Okay. So again, you set aside 1/2, and then e raised to 2 times 2 for your upper limit minus e raised to 2 times 0 for your lower limit. So bring down 1/2, answer this. So basically, you will have e raised to 4 minus 1. Okay, so again, this is 2 times 2, that's why this is 4. This is 2 times 0, that's why this is 0. Okay, and then any number raised by 0 is equal to 1. So therefore, this is your final answer. Okay, take note that in definite integrals, your answer is still expressed in terms of e. Okay, so it's still e again. So for indefinite and definite, you will still get e as your answers. And then let's have letter D. Now for letter D, we find the antiderivative of e raised to x from 1 to ln of 2. Okay, so this one is that, I mean, it doesn't get affected by this sign. So it's basically e raised to x again. Okay, all right. And then now we find for the limit from 1 to ln of 2. So basically e raised to ln of 2 minus e raised to 1. So pressing this in your calculator, you'll get 2. Okay, so Sec 4, are you familiar with your calculators? Can you find this? Okay, so e raised to ln of 2. Please inform me if you cannot, I mean, if your calculator works different, a different way. Okay, when you type this, and when you plug this in your calculator, you're supposed to get 2 as your answer. And then e raised to 1 is simply e. Okay, so this is your final answer. So 2 minus e. Okay, so do you have any question, class, for exponential functions? None? All right. All right, so this is my last example. Okay, so this is partly a word problem. Okay, all right, so find y as a function of x given that the derivative of y is equal to 2e raised to x plus 1 and y is 3 when x is 0. Okay, so first we need to find the y value because this is the derivative of y. So how do we go back to the y value? Basically, we need to get the antiderivative of this. Okay, so getting the antiderivative of this derivative, so the original equation was 2e raised to x plus c. Okay, getting the derivative of this, okay, it's the same. Okay, it's the same. Okay, again, it didn't change, right? Because the coefficient of x here is 1, so 1 times 2 is still the same. Okay, so plus 1, so the antiderivative of 1 is x and then plus c. So basically this is the value of y. So y is equal to this. Okay, but then before you can get the equation, we need to find for the value of c, right? We cannot have a c here. So we're given y is 3 when x is 0 from here. So we just plug this uh, in your equation. You'll get c is equal to 1. Okay, so therefore, this is your final answer. Y is equal to 2e raised to x plus 1.